In this video, we're going to be looking at the gradient and the intercepts of lines a little bit more detail using the equation y equals mx plus c from earlier. Okay, so straight lines on graphs always have this general equation, and you want to be thinking of this equation as soon as you see a question about lines, because this gives you the framework in which to attack these questions. So if I just refresh what we should be doing with this, m is the gradient, so we need to find a number to go into there, and then c is the y-intercept. So we need to be able to find both of these things. With this question here, we have a line which goes through 2 points. So I would always advise a very quick sketch. 1, 2 would be something like this, A 1, 2, and B 5, 10 would be somewhere up there. So a quick sketch like this will help us to see that our line is going upwards from left to right, so it's positive. And we can see here that we can get like a rough idea perhaps of our y-intercept. Not that we would be very accurate with that, but it helps us to sort of see roughly where that might be. Okay, now can we work out the y-intercept right now? Not easily. Okay, it's a lot more straightforward to work out the gradient first. Okay, if we can get the gradient first, we can work out the y-intercept more accurately later. So how do we work out the gradient of the line? We do a triangle and we do rise over run. So change in y divided by change in x, however you do it. So from 1 to 5 is a distance of 4 along the x-axis, and from 2 to 10 is a height of 8. So to go from 2 to 10, I have to go up by 8. So my gradient, m, is rise over run, which is 2. So now we've worked out that the gradient is 2, we can rewrite our equation with the 2 now in place. So we know the gradient's 2, but we don't know what the y-intercept is. To work that out, we can take either of these coordinates. Sometimes there's only one to choose from, okay, but in this case we have 2. If you have a coordinate that the line goes through, we can substitute the x and the y into this equation. Okay, that's very important. If you want to find the y-intercept, substitute one of the coordinates. I'm going to choose A because the numbers are smaller, so either one will work, but I'm going to choose A. X is 1 and y is 2. So I'm going to put a 2 in for y equals 2 for the gradient, and x was 1 and plus c, like that. So I replaced x with a 1. The 2 was already there from the gradient. Okay, that could be a little bit confusing, but I tried to highlight that the y value was the 2 from here. Okay, so we clean up this equation. 2 equals 2 times 1 plus c. Subtract 2 from both sides, and I get c equals 0. Okay, so from my sketch here, I wasn't far off, but this line actually goes through 0 for the y-intercept. So it goes through the origin. So when I rewrite my equation here, y equals 2x plus 0, I probably wouldn't bother writing that. That would get me the marks. But I've got y equals 2x is my final equation. Okay, so let's try another one. I'm going to just choose 2 points. Let's say A is 2, 5, and B can be 4, 9, like that. So we have a line going through these 2 points, and essentially we're extending it along to try to find the y-intercept, and we need the gradient. So y equals mx plus c is our framework. We try to work out the gradient first because we've got these 2 points. So run 2 to 4 is a distance of 2, and 5 to 9 is a distance of 4. So our gradient is rise over run, which equals 2, and then that can go in here. Okay, so we follow a very similar pattern. We're doing the gradient first, and then plus c. I still don't know what this y-intercept is, so I now need to use my coordinates. I'm going to choose the smaller numbers again because it makes my calculations easier. Y is 5 equals 2 lots of x, which is 2, plus c. Okay, so I substituted x as 2 and y as 5. Tidy this up. 5 equals 2 times 2, 4 plus c. Subtract 4 from both sides. 5 take away 4 is 1. So I've now found the c value of 1. I can finally rewrite my equation y equals 2x plus 1. Okay, so this is a very common question where you're trying to find the gradient, and then you can use one of the coordinates to find the y-intercept and therefore the final equation of the line.